The problems on the back side, all of these questions are asking about the rate of change. So we see the words, rate of change, right? Rate changing, of average cost. And so those are the key words you're looking for. If you see rate of change, that means a derivative. And then you should ask for rate of change of what? And then we see average cost. So we see rate of change of average cost as part of this problem, which means that we want to find the derivative of the average cost function. The average cost function is just the given cost function, 375 plus 0.75 x to the 3/4 divided by x. So average cost is just the total cost divided by the number of units. So if I have this formula and I want to calculate the derivative, the easy way to do this is just with the quotient rule. It becomes very long, but again, all I'm going to do with it when I get the answer is stick 81 in for x. So I don't mind if the numerator is complicated. So what I'll have is the derivative of the numerator. So let me just write that down. Derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all divided by the denominator squared. So that's going to be the derivative of this piece. The derivative of 375 is nothing, right? I mean, it's 0. And I have 0.75 times 3/4 and that's times x minus the derivative of x is just 1, so what I'll have in parentheses here is just exactly the stuff that was originally in the numerator, and that's all divided by x squared. So the answer to the question is, what is a prime of 81? And so I can just put 81 in for x in this expression, and that will give me my rate of change. So let me just do that in the calculator. So I get the derivative at 81 is about negative 0.06. And the unit here, remember the units are the it's the y-coordinate cost per x-coordinate. I mean the y-coordinate unit per x-coordinate unit. And so here the x-coordinate unit is in bottles, so it's going to be, let me get rid of some of, I guess I can't really get rid of it. So it's going to be dollars per bottle. And we can see that that's negative, so it's about 6 cents. $0.06 is about 6 cents. So it's decreasing. It's a negative change. So we expect that the average cost per bottle is going down at a rate of about 6 cents per bottle when you're selling or when you're manufacturing 81 bottles. And so that's kind of what you would expect, that when you're manufacturing stuff, that if your fixed costs stay the same, then your per item cost should be falling as you increase the number that you're producing. The problem below that asks the same question for average revenue, and this is a little bit easier to work with because the revenue function is just based on how many you sell, not based on, doesn't have a fixed cost stuck in there. So we have the revenue, 7.5 x to the 0.7 over x. So average revenue is just total revenue over the number that you sell. And so this is 7.5 x to the minus 0.3. And so the derivative of that, again, this is what we're trying to find. We want to know the rate of change, right? Rate of change of the average revenue. So this is the average revenue function, and so we want the rate of change of that. And so the rate of change is going to be 7.5 times negative 0.3 x to the negative 1.3. So again, I have to be careful with my derivative rules. I have a negative fractional number there, so I have to make sure I subtract one correctly from it. But that's my average, the rate of change of average revenue. And so therefore, at 81, I'll get approximately, stand by. So the derivative of average revenue is about negative 0.007. And again, this is still dollars per bottle. So my average revenue per bottle is also falling when I get to the 81 bottle mark. So it's falling by 0.7 cents per bottle. So my average cost is going down, but so is my average revenue, which I kind of expect both things to happen. And so the question is, what does that effect does that have on profit? But profit down here, the profit function, remember, is just revenue minus cost. And so the average profit is just average revenue minus average cost. And so we know from our derivative rules that the derivative of this side will just be the derivative of this minus the derivative of this. This minus sign, we just do this derivative and this derivative. So it really will be the case that the average profit is just the average revenue minus the average cost. And so the derivatives will also have that relationship. So the rate of change of the average profit is just going to be the number we got for revenue, negative 0.007, minus the number we got for cost, which is negative 0.06. And so that's approximately positive 0.053 dollars per bottle. And so when we're producing 81 bottles, producing and selling it, the average, the rate of change of the average profit. So the average profit is changing at approximately 5 cents per bottle, and it's going up. That's really the main thing. So our average profit per bottle is about 5 cents, the average profit is going up at about 5 cents per additional bottle produced. At no point here did I actually figure out what the average profit is, or the average revenue is, or the average cost is. We could do those calculations as well. All of these measurements are how fast those averages are changing. And so how fast the averages are changing. The last question just asks about how the profit's changing at the break-even point, and I put a little note down here because to do that you need to know what the break-even point is. The break-even point comes from setting revenue equal to cost and solving for x. And algebra-wise, that's not easy to do for this particular problem because the equations for revenue and cost are kind of funky with their weird exponents. So the only way to know that for this problem would be to put the two equations into a calculator or some kind of graphics device and see where they intersect and see what that x value is. There's no good algebra way to figure out that x will be 328. But the calculation you want to do here is the change of the profit, the derivative of profit at 328. So that is the rate that profit is changing, and compare that to the rate the average profit is changing. So it is tricky to think about what the units are for these two things because they'll seem very, very similar because this will be in dollars per bottle and this will also be in dollars per bottle. But this one, the measurement of dollars, is already the average measurement. So this is the rate of change of the average profit per bottle, and this is the average change of overall profit. So the interpretation is slightly different. It's definitely worth doing them and sort of talking out loud about it. But the reason we're focusing on this is that measuring the rate of change of profit, revenue, and cost is very common, but so is measuring the rate of change of average revenue, profit, and cost, and they really aren't measuring the same thing. So we're just jumping in and trying both things and comparing them and trying to get used to which one is telling us what.